I just had a so you guys started the chapter. We just tested. That means there's a bell word quiz coming up. I know that was a short chapter we just did. Well, we just finished a chapter. After every chapter is a bell word quiz. I know. Well, I'm thinking in order to get that in time. Never mind. We'll work on that bell word quiz next week. Yeah. Oh yeah, I gotta get that up. I'll get it up today. It'll be a test mediation if you earn less than a 60. And then there's 2 weeks of assignments roughly to go in.
Wait, say that.
Still left in third quarter grade is the test. Test remediation if you get less than a 60 and about 2 weeks worth of assignments. 2 weeks worth of assignments. Monday. Monday. Any other questions about that? Let's get started. So there's a possible bell word quiz to be rated, 2 weeks worth of assignments, a test remediation. Below 60. So if you're eager to get it done, I'll post it today. If you think you got a 60, you can start. But if you didn't get less than a 60, then you won't. It'll be.
How long do you think it'll take for the test to be done?
They'll be in by Monday.
What's the remediation do?
It'll be due by Thursday.
And then is the remediation on like big ideas?
Yeah.
Okay. Is it up already or
No. Yes.
What does it like do? Like, how much cover is it?
It just brings stuff straight to a 60. So anybody who does every assignment and does every it's impossible to fail. Alright. This tough part's Alright, so I'm supposed to go ahead and go to page 656 and highlight the important part. Alright, so the main thing looking at this definition of a rational function is it's a polynomial over a polynomial, which typically means there's variables and denominators. So that's really when I think of a rational function, I'm thinking, oh, x is in the denominator. We have our independent variable and the denominator of a fraction. So here's the parent function 1 over x. This is the most simple rational function. The name of this graph is a hyperbola. And a hyperbola is interesting because it's one equation graphed and it has 2 parts broken up into 2 branches. The other significant thing here on this parent function is that there are asymptotes. That was the vocabulary word with our exponential and our log graph. This has asymptotes that x is 0 and y is 0. So we're going to go ahead and create this graph to start. Let's jump into some notes here. Let's look at the parent function and how the hyperbola comes about. So we're jumping right to 7.2, and in fourth quarter, moving forward, I'll pick and choose the most important parts. So we're not doing 7.1, but I'll really you'll get it if you understand the rest of the chapter. No. Honestly, none of the rest of the chapters are too long. Alright, so the most significant feature of the parent function 1 over x is that x cannot be 0. There's an excluded value here. Mathematicians, they tried for a while. They wanted to divide by 0. They tried it. They really wanted to do it, but then every single time it was a crash and burn failure. So there's no dividing by 0. So that means really x could be anything except for 0 here. So because x can't be 0, we're going to have an asymptote there. This is a line that the graph approaches but does not go through, it doesn't cross, it just gets close to. There's an asymptote at x equals 0. So this table is not going to be the same for all of our graphs. With exponential and log graphs, we kind of use -2 through 2. This table is going to change per the equation. So this isn't consistent with all of our equations with this type of function. All right, I'm going to go ahead and start plugging in. I got 1 over -2, so my first ordered pair is -2, -1/2. Wait. I can't catch up. I don't know. Alright, I think you're all caught up now. So let me finish this. I'm gonna make a graph, gonna talk domain and range, and then I'm gonna do one more with you. Alright, we got a -1, 1 over 0, no good, undefined, no graph. No good. Don't do that. We got 1 over 1 is 1, and then we got 1 over 2, 1/2. Nice. Okay. Yeah, 0.5 is fine. You want to do your decimal, that's totally fine. Okay, so I'm actually going to start with the asymptote. I'm going to start with this knowledge that x can't be 0, and I'm going to put a dash line through there where x is 0. I know my graph won't hit that. Mathematically, it won't happen. Now, because x can't be 0, really y will never be 0 either. I could put anything in for x. I could put 0.2, negative 1,000. I could put anything for x. Nothing I put in x for x will ever yield y is 0. So I'm also going to say y will never be 0. And I'm going to do another asymptote. I'm going to do another asymptote there. So I have another dashed line through here. Now, where are these points going to end up? Negative 2, negative 1 half. Right here. Negative 1, negative 1. Right here. 1, 1, and 2, 1 half. What? That looks weird. Looks like a parallelogram. I feel like I want to draw lines through here and find angles. I got some acute and obtuse angles up there. No. Alright, so here's what we're going to do to get this shape done correctly. An asymptote draws a graph in at its end. So I'm going to put my pencil near the dashed line. I'm going to move to the points in a curvy way. I'm going to move through curves, and I'm going to end near a dashed line. The asymptotes guide your pencil. Start near a dashed line, move through the points, and near a dashed line. And that's the parent function. So domain, I'm going to list as x is a whole set of numbers, everything except for 0. And range is a whole set of numbers, everything except y cannot be 0. Let me do that a little better. Parenthesis, point, parenthesis. Yes.
If you point those points, right?
Yeah.
How do you know not to like take it the other way or like connect those or not? You know what I mean?
Yeah, you could always make a bigger table. Like let's imagine 3 would be 1 over 3, and 4 would be 1 over 4, 5 would be 1/5, which is 0.2. The dashed line. So you can't, because x can't be 0, it's undefined. It will literally make planes crash. It won't exist. It's like deflected now. The math doesn't work when x is 0, so it won't move through there. But I mean, without that knowledge, you end up with a zigzag, and yeah. And just keep in mind too that functions have to pass a vertical line test. There's that kind of concept there too. No, as soon as we put more numbers into this, those dashed lines are going to move left and right and up and down. So yeah, so our next step is to move this thing around. Let's do some transformation.
Whoa, wait a minute, hold on. We're gonna do examples. Are we gonna do examples in the book with this part? Are we gonna do examples in the book with this part?
Yeah.
Like a classwork.
This is our step.
Oh, okay.
We're gonna do 15 together. Okay. All right, so let's talk about moving those dashed lines. Like Anna kind of said on her own. Like, what about these dashed lines? So, really good point. So now, if there's a number that shows up under the fraction bar next to x, that's going to shift the graph left or right, and that'll also affect the asymptote. And they can also put a number here at the end, a constant, and that will shift the graph up and down, and that will affect the sideways asymptote. So put more numbers in there, and those dashed lines show up in different spots. So these are the steps we're going to use to graph. We have 3 graphs to do, and I'm going to do one with you. And then the rest of your problems are matching. So, this is the assignment here. And so the example I'm going to do for these points is number 15. So there's 3 graphs in this, and I'm doing that first one. I'm going to go through these steps with you. And 15 on 663 is going to be our example. All right, so step 1 is to always start with the dashed lines. Identify the asymptotes with the dashed lines. The dashed lines make the graph even more than the points do. Step 2 is to make a table. Your table has to include both sides, both branches. So you want to make sure your table has the asymptote in the middle. So 2 points to the left of H and 2 points to the right. Then lastly, you draw the branches using a curvy shape, starting with your pencil at a dash line and ending with your pencil at a dash All right, when you're ready, we're going to go to page 663 and do number 15 together. I'm going to keep these steps up and do these steps on number 15.
What is there?
Were you in that first sentence? Try them all.
Why is it just so?
So you're blurry.
All right, guys, so let's do step 1. We're going to start with dash lines at the asymptote. So we have a -4 down here in the denominator. So tell me, what can x not be? You guys, 0 minus 4 is -4. What can x not be? 4. 4 minus 4 makes a 0. Okay, so we don't write rules about x. We're writing a rule about the fraction. The fraction can't have 0. So you think, what would make it 0? Because 4 minus 4 gives me a 0 down here. It's the result after that math happens. You don't want an undefined fraction. I don't really care as much about x. Maybe it's what's happening down here that I don't want to be 0. So this time x can't be 4. Okay? Now, this other number here is our other asymptote, so I'm also going to say y will never be -1. The reason y will never be -1 is because this fraction will never be 0. There's no way to create a 0 right there. So my very first step is to do a dash line at x equals 4 and at y equals -1. Those will be the asymptotes. Yeah.
Is it x does not equal -4, or is it not equal 4?
It doesn't equal 4.
Why is it not negative 4? So it can't equal -4? That way I can find out.
What's the problem with denominators? Denominators can't be 0, right? So this whole thing can't be 0. So think about x. What would x have to be to make this whole thing 0? 4. Because this, it's impossible with this 3 here to create a 0 right here. The only way to get y equals -1 if it was 0 minus 1. There'll never be a 0 there, so y will never be -1. The reason why it can't be -1 is because that fraction in front of it will never be 0. It'll always have some kind of value to it. So it'll never perfectly be -1. Alright, so here I go with dash lines. The dash lines are more important even than the points. Dash line at 4. Dash line at -1. And we need to put the lights on. The only reason I need it is because there was a glare right here. I'm good. Leave it. That's good. That's good. Alright, so let's make a table. Number 2 is to make a table. Now the table's gonna be different, you guys. If I just make a table between -2 and 2, I will only have one branch of the hyperbola. So if I just use these x values, I'll only be here. I need this to be the center of the graph. So this has to be the center of the table. So when I go to make my table, I'm putting 4 in the middle. The undefined x value goes in the middle. It's okay. I've gotten used to it, but I've done it now for like 2 years. I would use graph paper if I were you, but I quite frankly enjoy graphing. No. Alright, so okay, so I want 2 points to the left and 2 points to the right. So I'm gonna go 3, 2, 5, 6. A completely different table. I don't rely on the same x values. I gotta have something in the center there. So go ahead and do the math, plug in, and this would be -3 over 2 minus 4 minus 1. -3, 3 minus 4 minus 1. -3, 5 minus 4 minus 1. -3, 6 minus 4 minus 1. You put that in the calculator if you want. Or do it by hand if you want. Alright, I see this as 1.5 minus 1, so my first ordered pair will be 2, 0.5. I'll pause so you guys can do that too.
Is it right over to 1.5? This is a chalkboard.
What? I'll ask your calculator. Can I use my phone?
No, but you can use your own brain. It's not that tricky. You're capable. You do 3, I'll do 5. Okay, let's count these points. 2, 0.5. 3, comma 2. 5, -4. 6, -2.5. Looks very similar. 2 points at a diagonal. I will say this time the two dots are in the other quadrants, and that's because the 3 is negative. So now the branches have kind of a negative slope instead of a positive slope. Now, step 3 is connecting the points correctly. Use the dash lines. You start with your pencil at a dash line. So many students are going to start their pencil at the orange line. But the orange line is just an accent. You start your pencil at the dash line. You move towards the points, through the points in a curve, and near the dash line. What's that? Yeah. The first one we did is the most basic, and the most basic is always right in the middle. And now we've shifted it right. They're wide. They are. This is quadrant 1. But this is the branch of the hyperbole. Alright, this is it, guys. So I'm already figured out. I have it
It does.
It's not so much.
I know, like,
You can do it. Aiden, why don't you tell us domain and range for this guy?
because I don't know.
I don't.
You don't think you can do it?
Wait.
How about you do it?
All right.
Oh, X. Oh, I get it. I get it. Would it be X equal to 4?
X can't be 4.
The X can't be -1.
And Y can't be -1.
Yeah. Okay.
The domain and range is everything excluding the asymptotes. All the things except that asymptote. It's the same number that is the asymptote in step 1. Exclude it. Alright, end behavior. Try to do one. On the left side, when x is going towards negative infinity, the y value is going down to -1. And on the right side, when x is heading to positive infinity, the y value is going up to -1. So the ends are doing the same thing. It's the middle that gets wonky, but on the ends, they're both going to -1. Because there's asymptotes, and that's what asymptotes do. They draw graphs towards the end.